In this question, it is given that 5 rods of same dimensions are arranged as shown in figure. They have thermal conductivities K1, K2, K3 and K4. When the points A and B are maintained at different temperatures, no heat flow through center rod. So it is basically related to that current in Wheaton's bridge. So if there is no temperature, or there is no heat transfer between these session, so that means the temperature of this point and this temperature of this point is same. So with respect to the concept of current electricity, we can just consider that the potential of this point and potential of this point is same. So we know that in Wheaton's bridge we'll remove this resistor. So what is the condition for that? So according to the concept of Wheaton's bridge, we know that if we are having a resistor over here, let's say R1, and a resistor over here, let's say R2, and a resistor over here, so according to this question I'm just treating it as R3, and there is a resistor over here, let's say R2, there is a resistor over here, take it as R4, and there is a resistor which is connected in between them, let's say that is equal to R5. So here you can say that the condition for balanced Wheaton's bridge is when the value of R1 by R3 is equal to the value of R2 divided by R4. Then using the concept of Wheaton's bridge, we can say that the potential of this point and the potential of this point is same. So we can write the same condition for resistors also. So this R1 can be written as nothing but L divided by, we can write it as K, or this is K1 into the value of A, area of conductor, which we can take it as A. So this will be the value of R1. Like that, for all the resistors, the dimensions of conductor means L and A are given same. So we can write this R is basically inversely proportional to K. So this R1 by R3 can be written as nothing but K3 divided by K1. Like that, R2 by R4 can be written as nothing but K4 divided by K2. So we can write the relation between them. So this, if you are cross multiplying this one, we can take it as K2 into K3 is equal to K1 into K4. So we'll get the relation same as like the relation the first option. So we can write first option is correct.